AET 114, Chapter 14. This is Basic Elements and Phasors, example problem 6. It says determine the inductive reactance in ohms of a 2 millihenry coil for the following frequency. So L is going to be equal to 2 times 10 to the negative 3 henries, which is 2 millihenries. And then part A is a DC frequency, which means 0 hertz. F is 0, omega is 0. So if we use this formula, X of L equals omega times L equals 2 pi FL. If F is 0, then X of L is going to be 0. Part B says for F equal 60 hertz. So using this formula again, 2 pi FL. If we multiply the 2 times pi times the L being 2 millihenries, we get 1.26 times 10 to the negative 2 times F. So if we substitute in 60 for F, we get 753 milliohms. And then part C is for 4 kilohertz. So 4 times 10 to the third hertz. If we substitute that value in for F, X of L equals 50.27 ohms. And then part D is 1.2 megahertz. So X of L for that frequency would be 15.08 kiloohms. Problem number 13 says determine the capacitive reactance in ohms of a 0.2 microfarad capacitor for similar frequencies. So you do the same thing. Your formula for capacitive reactance is X of C equals 1 divided by omega C. Omega equals 2 pi F, so it's 1 divided by the quantity 2 pi FC. Substituting in your values for part A is 0, so this denominator would be 0. 1 divided by 0 is infinity, so it'd be an infinite amount of ohms, an infinite amount of capacitive reactance. Part B, similarly, you substitute in 60 hertz and you get 13.26 kiloohms. Part C, substitute 2 kilohertz, you get 397.89 ohms. And part D, you substitute in 2 megahertz. Okay, so there's a typo in what they put in here. It's 2 megahertz, which should be 2 times 10 to the plus 6 hertz. But when you multiply it all out, the answer is correct. You get 0.398 ohms.